Hey everybody, welcome back to Mr. Carroll's Classroom. Today we're going to talk about quadratic equations and how they apply to the real world. So let's go ahead and get started. Okay, so first of all, there are many different real life applications for quadratics. Anything with a degree of 2 or an x squared in there. Anything involving parabolas, anything involving projectiles and trajectories, anything involving area optimizations. Let's see here. We got maximizing profits and revenue, and etc. There are just tons and tons of real life applications for these, and really in any situation where you have two variables being multiplied by each other, then there is a possibility for some kind of quadratic application problem. For example, if I'm calculating area, well, area is width times height, or length times width, or whatever you want to call it. But ultimately, I am multiplying two different variables together, and if I can figure out an expression where those involve the same variable, for example, something where we might end up like this, where the width might be like x minus 2 and the height might end up being, I don't know, x plus 2, whatever. Doesn't really matter. But ultimately, when we multiply this out, we'll end up with some kind of quadratic equation. Any type of projectile in real life. So in real life, you're going to throw something or hit something or shoot something off like a rocket or whatever. But ultimately, you got the ground, and the projectile is having gravity act as a force on it. So it flies or whatever in a parabolic shape in an ideal world, where you're taking out friction. So, and yeah, those types of instances occur all the time. And really anything that involves a parabolic shape. So like, I don't know, for example, say you have a dish TV or whatever. Ultimately, that thing is a parabola, the dish, with some kind of focus point in the center, and as little signals go down and hit it, they all bounce off and go towards that little focal point. So we could go ahead and use some kind of quadratic equation to represent that situation. How about, let's see, what else do I have in here? Maximizing profit or revenue. So maybe you're selling, you're saying your profit, you're selling so many, we'll say a ticket price to so many different people. So, right, so we have the dollar amount times the number of people you're selling it to. Or whatever, right? But ultimately, again, if I can figure out some kind of expression for the dollar and for the people where they are using a shared variable, that variable will end up multiplied by each other, giving us another quadratic. So yeah, these are kind of interesting problems. And again, we're going to start off basic today, though. Okay, so let's go ahead and do a couple of problems, see what this looks like. Okay, so here's our first problem here. And so let's read it off. You decide to make a rectangular fenced-in area for your dog around his doghouse. So you know that that his doghouse is 4 feet by 6 feet, right? This is somewhere out in your backyard where dogs used to have dog houses, right? But anyway, it is 4 feet by 6 feet. And you will have space X feet between the fence and the doghouse on all sides. So that's pretty important. We're going to have to like draw a picture here. All right. You also want the total enclosed area to be 120 square feet. That's an important little tidbit there. And we're going to write and solve a quadratic equation to determine the final dimensions of the fence around our dog's house. So with these clues, we're going to go ahead and first draw out the situation. So I've already kind of started this here. So this rectangle in blue is going to be represent your dog's house from the top down, and we said that it's 4 feet by 6 feet. All right, so let's go ahead and figure out what else we need here. I'm going to go ahead and label, first of all, what does it mean for let's see here. They have space X feet wide between the fence and the doghouse on all sides. So that means, like, from here to here is x, or here to here is x, here to here x, right? On all sides, I have this this length x, okay? So we can actually draw that fairly concisely by doing something like this. We could say, okay, well, here is going to be x, and we'll do here, which is also x. And then same with this, and same with that. And here is x, and here is x, and here is x, and here is x. So we could label all of these if we wanted to, but I guess it's not really that necessary, but I've done it anyway, so there it is. Okay, so now we know that, let me erase this here. We know that the total enclosed area, or at least we want it to be, 120 square feet. So that's really important. So the area of this whole thing, what should I say here? We'll do it like this. We'll say all of this. Total area is equal to 120 feet squared. Okay. Now, let's go ahead and start putting some of these clues together here. So I do have area, and we know that the area equation is, or area formula, is going to be the width times the height, or length times the height, whatever you want to call it. I'm going to call it the width times the height. Okay? Now, we actually know quite a bit of these. So first of all, the area is 120. So let's go ahead and plug that in. So I'm going to say the area is 120. Now, what is the width? Well, the width was 4 feet, right? Let's see. Grab another color here. So the width was this 4 feet. But now, it's going to be the 4 feet plus an x over here, and then an x over here as well, right? So it's really going to be now 4 plus 2 x's. So let's go ahead and write that in. So the width is now 4 plus 2x. Now the height, we're going to do the same type of thing here. So the height was originally 6 feet, but now this height is going to be 6 feet. It's getting a little sloppy here. It's going to be the 6 feet plus x on top and x on the bottom. So let's go ahead and put in that expression. So 6 plus 2x. All right, so here we go. We have this equation, which looks like it's now going to end up being a quadratic, because ultimately, when I double distribute here, it's going to be an x times an x. So let's go ahead and do that. So I'm going to leave the 120 on this side, and let's go ahead and multiply all this out. So I kind of wish I put the 2x's first, but that's okay. We'll say 4 times 6 is 24, and then 4 times 2x is 8x. And 2 times 6, 2x times 6 is 12x. And then 2x times 2x is going to be 4x squared. All right, let's go ahead and we're going to simplify this quite a bit. So the first thing I'm going to do is I'm going to go ahead and, I guess I'll combine like terms here. And I'm also going to, so 8x plus 12x is going to be 20x. But also I'm going to go ahead and reorder this, because I really want my x squared in front, or put this thing kind of in standard form. For now, I'm going to leave the 120 outside here, though. So anyways, so here I have 120 is equal to 4x squared plus 20x plus 24. Okay, you see that I just went ahead and reordered this. Okay, so the question is, how do I solve for x here, right? There are a number of different ways. All involve pretty much first putting this thing into standard form. So, meaning I want to get 0 on one side. So I'm going to go ahead and subtract 120 over. So let's do that. So I'll say 0 is equal to, and this is 4x squared plus 20x. And let's see here, 24 minus 120 is negative 96. Okay, so next step in solving for x, well, we have a few different options, really. We could go ahead and use the quadratic formula, but we're going to try to avoid that, because that's usually our last line of defense. We want to try to factor this. So the first thing I'm going to do to factor this is, actually, I noticed that all of these are divisible by 4. 4, 20, and negative 96. So, and since it's an equation, I can go ahead and divide both sides by 4. All right, I'm running out of space a little bit, so we'll probably have to move up in a second here, but let's go ahead and do that. 0 divided by 4 is just 0. 4 divided by 4 is x squared. 20x divided by 4 is going to be 5x, so plus 5x. And let's see here, 96 divided by 4 is, I believe, 24, negative 24 in this case. Okay, so now this looks like this is something that is manageable. I'm going to go ahead and kind of move this up here, though, okay, where we have some room. All right, so let's go ahead and factor. So I have 0 is equal to, we're going to use guess and check here. So x times x is x squared, and now I'm looking for two numbers that multiply to negative 24 and add to positive 5, and I believe that is going to be positive 8 and negative 3. 8 times negative 3 is negative 24, and 8 plus negative 3 is positive 5. So that looks like we're all set there. Okay? All right. So now we're going to use the zero product property to separate this out. If I have two things multiplied by each other equal to 0, then I can set each of them equal to 0. So we'll say that x plus 8 is equal to 0, and x minus 3 is equal to 0, which means that x is equal to negative 8, or x is equal to positive 3. So, we got two answers, which is what we expect out of all quadratics, to get two answers. But with these real life situations, usually one of these does not work. And the one that's not going to work is going to be the x is equal to negative 8. The reason is, what are we actually measuring? Well, we're measuring a distance, and it's impossible for us in the real world to have a negative distance. So we now have our final answer, which is going to be x is equal to 3. However, we want to write our the dimensions of our fence. So the final dimensions, where I can write this, I'm kind of out of room here. We keep moving up here. So final dimensions are going to be, let's see here, the width is going to be 4 plus 2x, right? We have two of these x's right here, and x is 3. So the width is going to be 4 plus 6, which is going to be 10. So we'll say width equals 10 feet. And the height, let's see here, the height was originally 6 plus 2 of these x's. So 6 plus 6 is going to be 12 feet. And there we go. We can go ahead and put a little box around our final answer here. So with x being 3, we have a final width of 10 feet and a height of 12 feet in this situation. Okay? Oh, by the way, this is a very common type of problem for quadratic applications, especially because with area, remember, we always have to, like, if we want to apply something quadratically, you have to have an x squared or a variable squared in there, and the area formula is width times height. So we're probably going to end up multiplying two variables together, getting that x squared. So you'll see area optimization problems frequently. Okay? All right, let's go to the next problem here. Okay, so we have another type of area problem, and with same thing with fences, because these are the types of problems we love to give. Okay, so here we go. You decide to make another rectangular fenced-in area in your yard for your dog to play freely during the day, right? You only had enough money to buy 40 feet of fencing, and you want the total area to be 150 square feet, so your dog can get the most out of the play area. Okay? Pretty big points there, right? We have a total of 40 feet of fencing, and we want the total area to be 150 square feet. All right, after learning about quadratics in school, you realize it would be beneficial to utilize the side of your house as one of the sides of the rectangular play area. So that way you don't have to use fencing for one side of your rectangular area. You'll use the house instead. So given that, what dimensions should you make your fence? So first things first, as always, we will go ahead and draw our situation. So here in blue, I have just a rectangular cutout of our house. And you can see that here we have our play area right here. And it's going to be, so far, I've just got it listed at 150 square feet. Okay, so let's go ahead and figure out this problem. One thing I do want to note is that the area, let's see here, we'll say area, Actually, let's just go ahead and underline this, I guess. The area, where's my area at, is going to end up being 150 square feet. Grab a different color here. Okay, so area is going to be 150 square feet. All right. Okay, so the rest of this is really to figure out these two different dimensions. So I'm just going to kind of label these. You can label them W for width, length times height, or X's and Y's, whatever. Doesn't really matter. I'm going to go ahead and just label this W and this H for width and height, but again, it doesn't really matter. Now, I do know that if this width is W up here, then I also know that the width is W down here. Okay, so all right, let's start listing some of these things. So we know the area is going to be equal to 150, which is equal to width times height. Okay, but there's actually one other thing we know. The other thing we know here is related to the 40 feet of fencing. We know we're going to use a maximum of 40 feet of fencing because we're going to use all of it, right? And that is equivalent to the perimeter, okay? So we can say the perimeter is equal to, not 150, 40 feet, okay? Which is, by the way, equal to what? Well, in this case, it's W plus W plus H. Okay, so let's go ahead and write that down. That's 2 W's plus H. All right, so really important here. So I have 40 is equal to 2W plus H, but I also have 150 is equal to width times height. Now, we can't really get a quadratic equation if we have two different variables, right? So what I want to do here is I want, instead of W times H, I want W times some other expression with a W in it, or I want H times some other expression with H in it. So what we can do is we can utilize this perimeter over here to solve for one of our variables and then plug it in over there. Okay, so that's the idea here. And then we will end up with a quadratic. So let's go ahead and I am going to put a little arrow here. And I think it's going to be harder to solve for W because we'll have to divide by 2. So let's go ahead and solve for H here. So I'm just going to subtract 2W over, and we're going to say H is equal to 40 minus 2W. Okay? So what we want to do is we want to take this, and we're going to go ahead and substitute that in for H. So let's go ahead and do it. All right, so I am left with here with 150 is equal to W times not H anymore, but 40 minus 2W, which is what I got from here. And now you can see I am going to end up with a quadratic because I'm going to multiply this W in, or distribute it, and we'll end up with a W squared. So let's go ahead and do that. So I'm going to leave my 150 over here is equal to 40W minus 2W squared. All right, so we have a quadratic. Now we're going to go ahead and start solving this thing. So first step in solving is going to be get one side equal to 0. And what I think I'm going to do, since I don't like a negative here, is I'm going to move everything over to the other side. So let's go ahead and do that. So I'm going to add 2W over. So let's go ahead and write that. So 2W squared. And I'm going to subtract the 40W minus 40W plus 150 is equal to 0 on this side now. All right, now I do notice that everything is divisible by 2. So I'm going to, since it's an equation, I am going to divide both sides and everything by 2, getting W squared minus 20W plus 75 is equal to 0. And now it's time to factor this thing. Okay, so let's see. Factoring, let's see. We got W and another W here is equal to 0. And so now I'm looking for two numbers that are going to multiply to get to 75. and we're going to add to get to negative 20. So they're both going to be negative. We know that. And let's see here. Looks like, do we have 15? Does 15 go into 75? 15 goes into 75 5 times. So I think it's going to be 15 and 5. Okay. 15 times 5 is 75. Negative 15 times negative 5 is positive 75. And negative 15 plus negative 5 is negative 20. So now we can go ahead and separate this out. Kind of running out of room here, but that's okay. So I'm going to go ahead and I'm going to say w minus 15 is equal to 0, and w minus 5 is equal to 0. And we'll solve for w for each of these. So w is equal to 15, or w is equal to 5. That's actually kind of interesting, right? We have two different answers here. And so, and they're both positive. They're both positive. So let's go ahead and see what this means. So let's see here. If w is 5, let's see. Let's go ahead and we'll put in our answers here. So I'll say, let me use a different color so we can separate this out. So if the width, see if I have enough room here. Kind of put them over here. So we'll say if w is equal to 5, then what is h in this case? So let's go back up to our formulas here. So we know we have 40 feet to work with, right? So if w is 5, that means h is going to be right here, which is 40 minus 2 times 5. So h is going to be 30. All right, to get us our total of 40 feet of perimeter. So that's one solution. And by the way, let me just check this, right? Is 5 times 30 150 square feet? Yes, it is. Okay, so that works. Now we have this other solution as well. If w is equal to 15, then what is h in this case? Let's see here. Let's go ahead and plug that w in. So that would be 40 minus 2 times w. And in this case, let's see here. That's 30, so it would be 10. 40 minus 30 is 10. And again, we're going to double check this. If the width is 15 and the height is 10, and we calculated the area is 15 times 10, 150, the answer again, yes, it is. So actually, there are two solutions to this particular problem. If we have 40 feet of fencing, and we're going to use our house as one of the sides of this rectangular area over here, and we want our ultimate area to be 150 square feet, then there are actually two separate solutions for this. We can either have our width being 5 and our height being 30, or we could have a totally different shape here and make our width 15 and our height being 10, right? And so we have options, which is awesome. Okay. All right, guys. So there are a couple of our first examples for quadratic application problems. We will continue to do application problems throughout this unit because there are just tons and tons of them, and these are just a few examples of what you can do with just factoring. Once we get to graphing quadratics and really exploring a lot of more of the intricacies of quadratic graphs and the algebra behind it and all that, we will have a lot more problems just attacking from different angles. So anyways, okay, so there you guys go. Hopefully you got something out of this lesson, and we'll see you in the next one. Take it easy.